You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. My guest today is Jonathan Delafield-Butt, Dr. Jonathan Delafield-Butt. He's the director of the Laboratory for Innovation in Autism, University of Strathclyde in Glasgow, Scotland. He's also a contributing author to Infant Minds, Origin of the Social Brain. That's a book that he has a chapter in that he authored. So, Dr. Delafield-Butt, thanks for coming. I appreciate you being here.
How are you doing today?
Very good, yes, and thank you for inviting me onto your podcast.
Yeah, so you focus on infants and their mindset, I guess, and their development. What got you into this area of study?
Well, infants in particular, because it's the first expression of the human mind in a body, and I'm very interested in the nature of what is the mental or our experience. It seemed to me quite a good idea to start at the beginning. In fact, in my postdoctoral work and in the work before that, I studied chemistry as an undergraduate student, and then moved into neuroscience for the same reason, to understand the structure, the composition, and the origins of the human mind. Neuroscience being a very good beginning of that, since a lot of our experience is contingent on the brain, and the brain is made of cells which are made of chemicals, so that fits together. But then to really understand the expression of experience of the mind, then we need to look at the whole living organism. And the first instance of that, arguably, is at birth. But what our work has shown, and many others, is that in fact experience doesn't just begin at the caesura of birth, but in fact it's an emergent or gradually developing process, which has obvious characteristics at birth and in babies. So that's what got me into it, and that's why I study babies, because it's the first expression of a whole human mind working in concert with other people.
Yeah, I guess that's why there's a debate as to when a woman's pregnant, at what point is the fetus alive or conscious of what's going on? So I guess consciousness begins from someplace and then evolves and becomes more and more until the baby's born, and then keeps going from there.
Yes, and I think that's something of the picture that we're developing, and we can start to map that out by not only understanding brain development and the development of the body, so the skeletal musculature and the way that the nervous system is able to innervate and to control that for its own purpose, and which is really an important feature for its own purpose. Because as soon as the organism can act of its own volition or of its own will, then it has agency in the world and must, by necessity, be conscious of it in some degree. Consciousness being the thing of knowing, or the thing with knowing. So the infant, as soon as it has that capacity, we can argue, is conscious. And it's a question then of not laboring ourselves with unthought through baggage of what we mean by consciousness. So we use a very operational definition of acting with some semblance of knowledge. And that can be observed in the particular motor act, the actual movements of the infant or the movements of the fetus, or indeed, if you want to push back further, the movements of the developing embryo. So in terms of that growing organism and that development of conscious awareness, it's a very interesting question, and one way to start to pinpoint this emergence of consciousness and the development of human agency is to map with empirical precision the detail of movement and try to discover with reason and logic when those movements are first organized with an awareness of where they're going. And when that awareness is active, then we can say with some degree of certainty that infant is acting consciously. So this is very much an important question, and you're right. It's not it doesn't just switch on at 9 months post coitus, as it were. It doesn't switch on at 9 months after birth when the first semblances of language begin to appear. It's something that develops gradually, but I think it's important to map out as incremental steps.
The weird thing is, how can we have consciousness but no memory accompanying it? Like, I've never heard of anyone that remembers their birth. I've never heard of anyone that remembers being in the womb. And, if you think about, it's weird, I guess we probably remember 1/10 of 1% of all the days we've ever lived, yet we still are who we are. So it's weird,
Yes, but do you remember what you were doing, 3 years ago, in detail? And the answer is perhaps not quite precisely. And memory is a very interesting thing, and that's another kettle of fish. But of course, we typically think of memory as being the memory that's accessible to verbal recall or articulating it in language. So we're speaking using words, and that has a specific, very precise, defined knowledge. But memory is richer than that, and we know that from experiences of trauma, for example, how the memories become embodied and they're encoded in patterns of association and arousal, the affective or the feelings that are associated with particular events that are common to that trauma. So we don't just have a verbal explicit memory available to verbal recall, but we have an implicit memory, which can be encoded in different ways. And how precise and how well mapped out our early experiences are in terms of our fetal life or our very early infant life or our child life, is another question. And there's lots of experts probably with much more detailed knowledge than I about that. But in terms of psychotherapy and psychotherapeutic processes, a lot of those processes are working back to rediscover, as it were, those very early memories, especially when they are of a traumatic nature that has caused development to proceed in a way that's not very healthy or very beneficial for the individual. So the point is there is a memory, but it's not perhaps an explicit memory. It's more implicit.
Well, all right, so what's the consequence of that? What have you learned about infants and their cognition levels? And what kind of surprises have you discovered?
Well, some of the earlier work was been very interesting. So one of the questions that we've had to give a kind of precise definition to when does the infant, when can we say the infant is conscious and acting with its own intention? We've worked with a philosopher, Nivedita Gangopadhyay, who came from Dan Zahavi's Center for Subjectivity Research in Copenhagen, taking philosophical principles and we worked to apply those to the biomechanical precision of mapping out human movement. So one thing that's interesting about human movement is we need to know prospectively where the movement is taking us, and this is ingrained in the biomechanical properties of the human organism and the way that the nervous system organizes those movements and the lawful consequences of moving, which are inertia and momentum in particular directions. So in biomechanics, they use a terminology called prospective organization. So there's a prospective organization of any particular movement. So it acts with a awareness within the body of where it is going. And we looked at that in terms of its definition, and that equates very comparably to the notion of intentionality. So knowing where you're going. So it's an intrinsic intentionality, what we call a primary sensory motor intentionality. And you can map out the prospective organization of movement because it's observable, whereas the mind, the first person experience, is arguably not observable. But we can observe the intentionality as parsed in the movements of the individual child or the individual infant. So we mapped these out, and we came to understand that this prospective organization is very evident at birth in terms of its spatiotemporal pattern. And then by looking at the work of other people and some early conversations we had with Daniel Stern from New York and Alessandro Piontelli at the University of Milan, we began a more qualitative examination of fetal movement. At about the time that we were looking into this, some groups from Italy started to produce some very nice mapped out spatiotemporal data on the arm movements of fetuses. And what one of those papers showed was that a fetus will reach to touch the other twin, in the case of a twin pregnancy, with a different action pattern than it will use to touch the placental wall or the umbilical cord, so the relatively inanimate objects of environment. But that action pattern is closely comparable to the movements that it will make to touch his or her own face. So what their data are showing is that the twin, in the case of a twin pregnancy, appears to have the first semblance of awareness of another animate other in its environment, which is similar to him or herself. And that is evident at about 14 weeks gestational age, which is the beginning or towards the beginning of the second trimester. So it's a very early time to think that actually the fetus might be aware in this rudimentary way, but nevertheless aware of the effects of the action that it's creating. So that's the fetus's own self-generated action. And it's demonstrating a prospective awareness, an anticipatory awareness of the consequences of that action.
So how sophisticated is the cognition of the fetus? You talked about reaching for its twin, let's say, at 14 weeks, but close to term, do we see a lot more sophistication, or is it kind of stay at a base level, through birth?
Yeah, well, this is where, interestingly, memory might come in to play a role, and also, where the development of the brain fully plays a major role. So, at 14 weeks gestational age, the nervous system is still quite immature, so that the cortical layers have not formed fully. Thalamocortical connectivity, so connecting the cortex to the midbrain and to the brainstem, and therefore the rest of the body, is not fully formed. So the cortex, for all intents and purposes, is relatively offline compared to how it will be in a few months' time near to birth. But yet that infant, or that fetus rather, still has a lot of control and is demonstrating this anticipatory awareness, which suggests that that awareness is a very fundamental structure in the nervous system and is not cortically dependent. So it's not dependent on the neocortex, which is our most evolutionarily recent addition to the brain. So it's something very fundamental and something shared with other animals. And this leads us to the notion, which Jaak Panksepp, the affective neuroscientist at the University of Washington, first made out, that in fact we have this layered conscious awareness, or this layered awareness of the actions of our cells on the world, and the brainstem mediated one is the primary layer, and what he termed simple the core self, using capital SELF, and he termed simple ego type life form. So this core self is dependent on the integrative action of the brainstem and not the cortex, and it is nonetheless aware and can be conscious and can evaluate the world and act purposefully, make a decision, act purposefully within the world to engage the world to produce effects that it particularly desires. So this is the very beginning of our experience as a complex human self, is this very early core self. And what's interesting is that core self never disappears, of course, but everything gets built up around it. So that basic brainstem integrative structure is still there in all of us, and it's still experiencing the world and acting out within it very fast, I should say. So it can act very quickly to changes in the environment, such as if you trip and fall, you don't need the cortex to adjust yourself and to correct your posture and stop yourself from falling. That can be done through more basic midbrain brainstem systems.
Wait, so is this Could you consider the brainstem a subservient but separate system of thinking?
Well, actually, it's probably the other way around. The cortex is probably subservient to the brainstem because the brainstem seeks to satisfy our needs. So it's also a visceral regulatory system. So it's regulating our autonomic system. It's sensing our proprioceptive senses, as it were, so our body in motion. And it has direct access to most of the information from the exteroceptors, the eyes, the nose, and the ears. And so it's sensing quite a lot. And one way of thinking about it is, although the brainstem is subcortical because it sits underneath the cortex, its function is probably supracortical, actually organizing the activities of the cortex. And this is this follows work of Jaak Panksepp, the late Jaak Panksepp from Washington, but also Bjorn Merker at Uppsala, a neurologist in Sweden, and indeed in the States, Penfield and Jasper from the 1950s, 1960s, with their cortical resection experiments. They were neurosurgeons, did a lot of work taking epilepsy and similar traumas or similar difficulties, and they were surprised in their neurosurgical experiments that actually they could remove large pieces of the cortex or take the cortex offline in the case of some surgeries, and still the patient would have a very high degree of residual consciousness. So they developed what they called the central-cephalic theory of consciousness, and this is a term that they introduced in the 1950s to share the notion that actually consciousness was centered at the center of the encephalon, the center of the encephalon being the midbrain brainstem structure, and was not so dependent as one might imagine on the activities of the neocortex, which is where neuroscience typically spends its time looking today. So we have a very neocortically centric view of brain function and of consciousness in neuroscience. And Bjorn Merker wrote an excellent paper in BBS about 10 years ago, bringing out all of the data on consciousness without a cortex and labeling it a challenge to cognitive neuroscience, because there's an awful lot of data that shows that actually you don't need a cortex to be conscious. You really just need the integrative machinery of the brainstem. So there's a lot of work in this area, and what we're beginning to understand now is that core self, contingent on brainstem, healthy, efficient brainstem integration, then becomes layered with memories from the midbrain structures and the cortical structures, and becomes more sophisticated in its abstract conceptual organization of those memories with the integrative activity of the neocortex. So, in a sense, all of our experiences are taking place through brainstem, and we're writing those experiences on a sheet of paper, which becomes convoluted and is the neocortex. So in terms of memory stores, we're also understanding that the brainstem does have associative memory, actually intrinsic to it, and is not dependent on other structures, hippocampus or so.
So, okay.
Does that help?
A little. I mean, so what does that mean? What's the consequence for, in looking at our minds? Again, do we have a separate brain, or is it just the brain at different levels will be predominant at different times, depending on what's going on with us or what we're doing? Or, when you boil this down, what does it mean?
Yeah, I suppose you're right, in a sense that some aspects will be, some areas of the brain, some parts of our cells will be more to the foreground than others. Depending on the need and your particular situation. So you don't want to be theorizing using the heavy machinery of the neocortex and reflecting on the world when you're playing a football game. You want to be acting very rapidly and becoming instantaneously aware of the other player's actions and responding to those using instinct, as it were. Rather than the heavy labor of thought. But at other times you may wish to think through problems, of course, and you would sit at a desk and think through problems. And these are abstract conceptual thoughts and abstract conceptual work that is dependent on the cortex. So I think it's somehow an interplay between these different layers and all of the memories and associations that we generate by doing things in the world and by learning about our effect on the world. So, yeah, I mean, it's interesting, but I think it would
And does this balance shift in infants? Or, again, what have you discovered that's unique about infants versus adults? I mean, if we look at an adult who's sleeping, you could say they're not conscious, or they just have a different kind of consciousness, So I guess who's to say that infants aren't just as conscious as we are in different ways? I don't know.
Yeah, so, I think that's the key, is that they are as conscious as us, but they don't have the same cognitive tools, as it were. They can't perceptually discriminate as accurately as we can, certainly, and that's mechanical in the very beginning of life. They don't have the same conceptual organization, the abstraction of ideas, the same rich store of memories, and so on. They haven't developed language, which becomes a really important tool of cognition. So they don't have these features that give us, our adult human, sophisticated technical mastery of the world. But they do have the basic human experience of being in the world with other people. And that is largely affective, as well as an understanding of how the world works. So babies communicate from the very beginning of life, and they communicate to engage with another person, a sensitive, caring person who's able to respond to their movements, their cries, their interest, and their feelings. And when these are responded to by a sensitive other who has noticed and wishes to respond or to care, then the infant responds as well, and we have this reciprocal cycle of communication and activity, and that's all conveyed through body movement, expressions of the voice, through the way that we adjust and shift our posture, the way that we might reach to pick up the baby, to hold the baby. Of course, once the baby is held, we have very rich experience of sharing our more autonomic physiology, our bodily feelings, heartbeat, respiration, temperature, perspiration. All of these things can then be sensed, and this is why, for example, at birth and in early infancy, the medical profession now typically recommends skin-to-skin contact to allow that embodied communication to really flow. But of course, we know that it's much richer even than simply through touch and sharing rhythms of breath. We're actually beginning to communicate in narratives or in stories. So the way that a baby moves in response to the mother's voice, or the father's voice, or the grandmother's voice, or anyone else's for that matter, initiates what we come to understand as narrative. So it's this beginning of a story, a shared story between individuals. So the infant responds to the feelings, the intentions in the voice, and responds with a similar affective contour or energetic contour in the way that the baby moves his or her voice and his or her arms and legs and her body, and that will in turn inform what the mother's doing. And as Dan Stern says, in these cycles of excitement, they tend to kick each other into higher and higher orbit until they are elated and joyful, and they come to a peak moment of excitation or climax of the narrative, and then they resolve and they come back together again, and they come back down to earth, and the story concludes, as it were. So that kind of mother-infant engagement, or that father-infant engagement, goes through narrative cycles, which we find in all time-based human arts, drama, music, poetry, and so on. They have a regular tempo. They have almost a musical structure in terms of the way that the voice is carried one to the other. In fact, Colin Trevarthen, who's spent a lot of work on this, has named it communicative musicality. There's a musicality in the communication that's conveyed between the infant and the adult. And that starts to generate meaning, because the infant starts to learn about the responses of the other, the way that they respond to the initiatives and the feelings of oneself, and where they lead to from each particular cycle or each particular iteration. And that leads to a knowledge of the other person, and therefore a future anticipation of what that person will do. And then that's a growing knowledge about how we are together in the world as embodied individuals, affectively embodied individuals. And that's the beginning of human communication, and that's right there from the beginning. And what's interesting is it's invariant, throughout human life. That narrative structure, the way that we understand and communicate with other people, remains invariant. And of course, when the baby learns language and is able to put words into that narrative, as the mother's already able to do and as the father's already able to do, then you have this significant enrichment of that communicative dimensionality, as it were, because you can name things, and each time you name something, it's not just the thing itself, but the experiences that you shared together with that thing. So all of the associations to that particular object. And then you're into the domain of language, and cognition starts to expand very rapidly and very significantly. And then you begin to enter into the world that we live in, which is predominantly communicated through words, through language, such as this podcast, for example.
Mm-hmm. Yeah, I'm here. So what do you hope to discover through your research? What are the big breakthroughs you're looking for?
Yeah, it's a good question. I think we need several things. So my work has a theoretical line, which is this embodied communication. My work also has a philosophical line, because it's a question of, well, where does if mind begins in very early infant development, if mind is actually shows itself to be expressed in very early fetal development, as some of these data strongly suggest it is, and as theoretically we know it is, then we have to push it back further, and we have to say, well, where does mind begin? And of course, when you push it back beyond the fetal period, you enter into the embryonic stage, and then you're into really biological principles of integration of experience from multiple aspects. And that starts to become a very strongly theoretical and philosophical question about the nature of experience and the nature of matter. And that's a particular metaphysical line, which I'm very interested in pursuing, because I think it will pay dividends later when we come to understand psychopathology and things of this nature. So absolutely, I think we need to address the metaphysics of mind and body and get properly metaphysical about it, in the sense of questioning the relationship between the mental aspect of experience and the physical aspect of experience, as it were, right down to its constituent physics. And on the other hand, we need to understand human meaning making in the development of infants, and how they learn to make meaning in the world, both alone and with other people. And then by extension to that, we need to understand the nature of neuromotor integration and moving in the world, because that's the core aspect of making meaning in the world, is because we're embodied, we move, interact with it, and create effects on the world, and that's how we learn about it. So I'm very much a proponent of an action-response psychology instead of a stimulus-response psychology, which treats the organism as being passive and reactive. Rather, we see the human organism as being active and generative, and creating its own experiences for its own purpose. And by extension to that, we need to really understand how disruption to movement can lead to thwarted development, such as, and my particular interest at the moment is in autism spectrum disorder, which we know now has a very strong motor component. And one of the questions there is, well, if that motor component is core to autism, as it appears to be, then, well, can we do something useful out of that, like measure it and therefore detect autism earlier? And we're developing technology to do that. Or can we understand the psychogenesis, as it were, of autism spectrum disorder, knowing what we know now about the disruption to movement in early childhood in autism? So, frankly, I'm trying to advance these three fronts: the metaphysics of mind and body, the development of human meaning making and communication, with the role of movement being central to that, and then how that motor disruption can lead to disrupted development, such as autism spectrum disorder.
Okay, well, very good, very good. Well, what's the best way for people to learn more about your research and about cognition in general? What kind of resources do you have for them?
Okay, so we have the lab website, which everybody's welcome to browse, which is it's the Laboratory for Innovation in Autism at the University of Strathclyde. If you Google that, you will find us. All my papers, or a vast chunk of them at least, are available on academia.edu or ResearchGate. If you're interested in the educational aspects of all of this, we've just published a book with Colin Trevarthen, who's a seminal child psychologist who initiated a lot of the work in intersubjectivity and human meaning making in infants, along with Dan Stern, working from the 1970s to the present day, and a colleague in education, Professor Eileen Wendy Dunlop, called the Child's Curriculum. So this takes these ideas and puts them into educational practice for improved pedagogy with all kids, especially young kids, and that's published by Oxford University Press.
Okay, very good. And your lab or your work, the best way to get to the website where all your work is listed is what?
Let me just look it up. So it is www.strath.ac.uk/research/innovation in autism, all one word.
Okay, very good. Well, Jonathan, thank you for coming. I really appreciate it.
Great. Okay, thank you for thank you for inviting me, and I look forward to listening to more of your podcast.
Oh, thank you.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.